Hello and welcome to another video of Smarty Academia Internationals. Our today's topic is going to be on solving polynomials and systems of linear equations using technology. First of all, we need to understand the concept of polynomials. There are many categories of polynomials. Let's say the first one is monomial. This means equations that have one term. For example, 3x, let's say 4x cubed, and so on and so forth. One thing that you need to understand for a polynomial is that the power of the variable, like let's say here it's 3, it's 1, it has to be positive integers, including 0. It can be a 0 as well, power of 0 as well. Like let's say we have a polynomial, or monomial, which is 3x power 0, which is actually a 3. But you need to understand it cannot have a negative power, else it will not be categorized as polynomial, which we will also see in our general term. We can also have a binomial. A binomial is an equation of polynomial with two terms. For instance, 4x squared plus 5, or 3x minus 6, or in certain terms 4x cubed minus 8. So these are all, or even x squared. This is also a binomial. The point is that it must have only two terms in the expressions. Similarly, as the pattern continues, we have a trinomial. A trinomial means any equation with three terms. For instance, 3x power 4 plus 4x plus 3. We often say we have a quadratic equation in the form of ax squared plus bx plus c. It is indeed a trinomial, but also a quadratic equation. Now, why it's called a quadratic equation, we'll come to that as well. So in general, the polynomial can be written in the form of ax power n plus bx power n minus 1 plus cx power n minus 2 plus dx power n minus 3, all the way where it ends to a constant. It is not necessary that a polynomial must have all these terms, but I just wrote this is the maximum order of a polynomial, and it can have some terms missing. For instance, in this particular example, we do not have the x3 or even the x2 term, which means that the coefficients of x3 and x2 are 0. So hence a, b, c, d, these are all coefficients of the polynomial. It can be 0, negative, decimal, fraction, it can be anything. It has to be a real number unless it's a real number. The second thing to understand is this particular power n, the maximum power in a polynomial. This is what we call the degree of polynomial. For instance, in this case, the degree of the polynomial is 4. For this question, the degree of polynomial is 3. For this question, degree of polynomial is 1. And for this expression, the degree of polynomial is 2. So the maximum power defines the degree of polynomial. And n, or n minus 1, or n minus 2, or all these positives should always be greater than 0, where all these belong to positive integers, basically. Means it cannot be a decimal, it has to be an integer. It cannot be a decimal, it cannot be a negative number, it has to be always positive integer. Let's try to see some examples of polynomial and see how it works. Now, for instance, if your n is 2, so I can say ax squared plus bx 1 plus c, where you stop at the last constant. You see 2 minus 2 is basically 0. So x power 0 is 1. So here we stop, as it cannot go negative, like 2 minus 3 will be negative 1. So we will not have these terms in our polynomial for degree 2. So this is what we say a polynomial with degree 2. And a polynomial with degree 2 is what we call a quadratic equation or a quadratic function. Now, it is not necessary that a quadratic equation will always be, or a quadratic function will always be a trinomial, because 3x squared plus 4x plus 1 is indeed degree 2, a quadratic equation, but it is not, it is a trinomial, beg your pardon. But 3x squared minus 1, it is again degree 2, it is a quadratic equation, but it is a binomial. Similarly, 4x squared, it is again a quadratic function with degree 2, but in this case, it's a monomial. So do not confuse these terminologies. The monomial, binomial, trinomial talks about the number of terms in the expression, whereas n talks about the degree. So this is what we understand by the term polynomials. And whenever you have, let's say, 3x squared plus 4x minus 3x minus 2, this you don't need to categorize as polynomial, because this is not a polynomial. Reason being is this negative sign. A negative sign can never be a polynomial. Next, we need to talk about the system of linear equations. Linear equation is what we define is a polynomial with degree equals to 1. For example, 3x plus 1, 4x minus 2. So the degree of the polynomial means x, which should be 1. So this is a linear equation, first of all. If it's 2, it's quadratic. If it's 3, it's cubic, and so on and so forth. And we have seen that in our previous courses, in our previous classes, that the degree of polynomial also talks about how many solutions it will have. Yes, quadratic equation can have no solutions, but it does not mean it does not have those two solutions. It will have two solutions, but it will be complex, not real solutions. So it will always have two solutions. So 3x plus 1 means it is linear polynomial. It is a linear function with degree 1. It means it will have one solution. If you have degree 1, the number of solutions would be 1. If you have degree 2, the number of solutions would be 2. If you have degree 3, the number of solutions would be 3. So this is something that you can always check using different polynomial functions, and we will see them as we go into our examples. Now, what are the system of linear equations? It's basically we need to understand that with the different systems, we can solve a multi-variable problem. For instance, we have two variables x and y in a system of equations, and these system of linear equations basically define a system, and a system means could be any observable system that has a mathematical model. That's why mathematics is used to actually solve real systems. So for two variables system having two variables unknowns x and y, you need two equations to solve this system of equations, system of two variable equations. If you have three variables x, y, and z, you would need three equations, and so on and so forth. If you have four variables, four equations, and so on and so forth. So remember, the number of unknowns should be equals to number of the linear equations. That's how you will get a unique solution. Unique solution means one solution means, for in this case, one value of x and y that satisfies the system of linear equations. In this case, one values not same necessarily means one value each of x, y, and z to satisfy the three linear equations, or in simple words, the system of linear equations. In order to solve the system of linear equations, we need to convert them into their standard form, as we saw the standard form of polynomials. So for a two-variable system of linear equations, the standard form is ax plus by equals to c, where c is a constant, a is a constant, and b is a constant. So these are the three constants. A and b are the coefficients of x and y respectively, and c is a constant. It can be 0 or any number. It can be even decimals. It has to be a real number. Secondly, if you have a system of three-variable linear equations, the standard form will be ax plus by plus cz equals to d, where a, b, and c are coefficients of x, y, and z respectively, and d is another constant that needs to be a real number. All you have to do is convert the system of equations into this form, and we will see how we can substitute in our calculator to find the general solution. Let's look at some examples. The A part talks about solving using technology. It has a two-variable system of equations with variables x and y. As you can see, it's already in general form, ax plus by equals to c. So the first equation, as you can see, 2x minus 3y equals to 2. Here a is 2, b is negative 3, and c is 2. For the second equation, 5x plus 3y equals to 5. Here a is 5, b is 3, and c is 5. Please note that we can also solve these equations using the method of elimination and substitution, but here for this particular course we need to understand that how we can use our GDC or graphing calculator to actually solve the system of linear equations. So let's get started. We need to go into the equation module. From here we need to select F1, which is the simultaneous equations. From here we need to select the number of unknowns. In our question the unknowns are x and y, which are 2, so I'll select F1. And here I need to put a, b, and c values of my two equations. As you can see, a is 2 for the first equation, b is negative 3, and c is 2. And for the second equation, a is 5, b is 3, and c is 5. So if I solve this, I get two values, which means unique values of x and y. So my answers are x equals to 1 and y equals to 0. So my unique values, or my unique solution using my calculator, is x equals to 1 and y equals to 0. And you can check both these variables solve the system of equations. So see, it's 2x minus 3y equals to 2, the first equation. So if I substitute, I put 2 times 1 minus 3 times 0 equals to 2. 3 times 0 is 0, so 2 equals to 2, which means my solution is correct. You can check by substituting these values to the second equation, you will still get the same answer. Now let's look at the second question. We have three variables in this question, x, y, and z. So it is a three-variable system of linear equations. As we can see, the equations are in proper format, which means ax plus by plus cz equals to d. For the first equation, my a is 2, my b is 1, my c is 3, and d is negative 3. For my second equation, which is this one, my a is 1. If nothing is written with x or y, it's 1. Here also it will be minus 1, so b will be negative 1, c is 2, and d is 1. And for the third equation, my a is 3, b is negative 2, c is 5, and d is 4. Now let's try to put this in the calculator and see what answer we get for x and y and z. That means a unique solution for this three-variable system of equation. To solve this, we will go into the equation module again. We will select simultaneous, and in this case our unknowns are 3, so we'll go for the unknowns 3, which is F2 in this case, x, y, and z. Now you can see we need to substitute the values a, b, c, and d respectively for all the three equations. So a was 2, b was 1, C was 3, and D was -3. For the second equation, my A was 1, B was -1, C was 2, and D was 1. And for my final equation, my A was 3, B was -2, C was 5, and D was 4. Now all I need to do is solve this, and I will get my x as 6, y as -3, and z as -4. So the value of x for this system of linear equations is 6, y is -3, and z is -4. Now in order to check the solution, we can choose any equation. Let's say I choose the third equation, which is 3x minus 2y plus 5z equals to 4. Substituting the values, 3 times 6 minus 2 times -3 plus 5 times -4 equals to 4. 3 times 6, 18. This will be plus 6 minus 20 equals to 4. 18 plus 6 is 24. Minus 20 equals to 4, hence 4 equals to 4, which means this solution, this unique solution of x, y, and z indeed satisfy the system of linear equations. Let's look at the next question. It says a triangle is defined by the lines with equations y equals to x plus 2, x plus y equals to 9, and x equals to 4. Find the coordinates of the triangle's vertices. So it means that we have these three equations and they intersect together, and the range, the area of intersection that it encloses forms a triangle, and we need to find the vertices of those triangles. So we need to plot these equations in the GDC and see that whether we get the triangle that it's talking about. In order to do so, we need to make, we know that y is always a function of x, or x is a function of y. So we need to convert in either two forms. Means we need to have a variable on y side on one side and the other variable on the other side. So the first equation can be written in this form, y equals to x plus 2. The second equation can be written y equals to 9 minus x. What happens? The x goes to the other side. Whereas the third equation, there is no variable y. So I can write x equals to 4. Now you can tell me or argue that there is no y, then how can x be a function of y? I can always write x equals to 4 y power 0. So y power 0 is 1, and hence y x equals to 4. It means it's a constant function. So I need to plot these equations in the GDC to find that triangle that will help me solve this question. To plot our three equations, we need to go into the graph module. From here, we need to write the equations. So the first equation was y equals to x plus 2. So I will choose my x alpha using alpha, and here, so it'll give me my x variable. I'll write plus 2. That's my first equation. The second equation would be y equals to 9 minus x. So 9 minus, go alphabet and x. Now, if you notice, every function is giving me y's, but I need to do x equals to 4. So I can change the style of my equation here. Type, if you see this type, if you go to type, you see y equals, r equals, and then x equals. So I want to do this x equals. So I'll go for x equals. You can see here. So if you go upwards, now it started my x variables. So the third equation is x equals to 4. So these are my three equations that I'm willing to plot. I'll just simply go exit here and just write x3 equals to 4. And so these are my three equations. I just need to go and draw them now. And as you can see, these are my three equations, and this is the triangle that it's been talking about. So we need to find the vertices of this triangle 1, 2, and 3. I can always zoom in if I want to. Okay, so now if you can see, I've zoomed in, and these are my what do you say, the triangle, as you can see. So I need to first solve. So I'll go to gsolve and find the intersection, and you can see the first point is 3.5 and 5.5. Now I can always use my trace function. If you can see here, we have a trace function to trace these values. If I use my trace, and I can just go and trace the values there, you can see, and try to find this point where you can see it's x equals to 4 and y equals to 5. So this is my second vertex of the triangle, and if I want to just, if you can see, I can always go here, and you just need to trace out, you need to figure out using the thing that what this value will be. And if you see, this is almost 4 and 6, so it will be 4 and 6. If you can see, it's 4 and 6 exactly. You can see here, this is if this is 4 and 5, this is 4 and 6. So these are the three vertices that I found, and using this I'm going to solve find the area of this triangle. So as solved from GDC, these were my equations, and this was my triangle that I found, this particular triangle, and I got my three vertices as 4, 6, 4, 5, and 3.5 and 5.5. So this is what my A part said. I need to find the coordinate of triangle vertices. Second B part says that I need to find this area, and I know that this particular line is a vertical line because it has the same x-intercept. So this is one thing that you need to understand. So I can draw the triangle like that. So I know it's a vertical line, it's not a slanted line. Okay, if it's a slanted line, then I'll have to use sine, cosine, or some other rules that we'll study later on. So we know that this has basically 1 unit, because if you see the y values, it moved from 5 to 6. So this is 1 unit, right? So we know that the area of triangle is half base times height. So we know that this is your base, and the height is, remember, the vertical height, the height. Now that one I can check from my x vertices. So we know that this is 4 and 5, and I also know that this is 3.5 and 5.5. Remember, if I just check my x vertices, so I know that this is 3.5, and I know that this is 4. As we can see here, this is 4 and this is 3.5. So this particular length, in this case, it's going to be 0.5 units. So you just need to be smart enough to actually try to extract the relevant information using coordinate systems. So we have the base, which is 1 unit. Remember, there are no units given, so you need to write units. We have the height, which is 0.5 units. All we need to know is find the area of the triangle, half base times height. So this is going to be half, base is 1, height is 0.5, and if you see, the answer would be 0.25, and you write unit squared, which represents the area of the triangle. The next questions are about solving the polynomials using technology. So before doing that, the way we converted our system of linear equations into standard form, we have to convert our polynomials into standard form. So what we need to do, we need to bring everything to this side. This will be minus 3x squared plus 8x minus 2 equals to 0. So you can see here, this is a standard quadratic equation. So in this case, we know that my a is -3, my b is 8, and my c is -2. All we need to do is substitute these values in the quadratic equations, and we will get two values of x in this case. To solve the polynomials, we will go into same equation module. We will select, in this case, polynomials now, which is F2. And here it says degree. Now remember, this was a quadratic equation with degree 2, so we'll select degree 2 in this case. And it's asking about substituting the value of a, b, and c. And we know our a was -3, our b was 8, and c was -2. And if I just solve this, you can see I get 2.3874 and 0.2792. I can also write them in surd forms, like exact form, which is 4 plus root 10 over 3, and the other is 4 minus root 10 over 3. So our first answer, exact, was 4 plus root 10 over 3, which was equal to 2.39, for like rounding to 3 significant figures. The second answer was 4 minus root 10 over 3, which is approximately equals to 0.279, rounding to 3 significant figures. Talking about the next question, it is clear we have a 3-degree polynomial, and we need to convert into standard form, bring everything to this side, which is in this case 3x cubed plus 7x squared minus 3x minus 2 equals to 0. So in this case, 3-degree polynomial, you will have 4 coefficients, a, b, c, and d. So 3a equals to 3, b equals to 7, c equals to -3, and d equals to -2. So these are your coefficients, a, b, c, and d. Sometimes you might not be given all these coefficients. For instance, you have a question 3x cubed minus 4. In this case, your a is 3, but remember your b is 0, your c is 0, and your d is -4. Because those terms are missing, that means you will put their coefficients equal to 0, whatever terms are missing. You will always use the standard form in order of decreasing powers until it goes to a constant. The same polynomial formula that I wrote on the top. So let's try to solve this question and see what are the roots, or it's also known as the roots, or the solutions to the equations. You should get 3 values of x. And let's see what do we get. To solve this equation, we'll go to equation module again. To solve this equation, we'll go to equation module again, select polynomials. The degree in this case is going to be 3, and we need to substitute the coefficients, which were 3, 7, -3, and -2. Once we solve this, we'll see we get 3 values. One is 2 over 3. The second is in decimals, cannot be written in fraction form, which means it's an irrational number. The third one also an irrational number. So the first value we got 2 over 3, which is approximately equals to 0.67. The second value we got was -2.62. And the third value approximately we got -0.381. So these are the solutions or 3 roots of this particular polynomial of degree 3. So this is all about solving the questions or any sort of polynomials or system of linear equations using your graphing calculator. The utility of graphing calculator is really high, and it's very beneficial in IB. It doesn't matter whatever calculator you're using, either you're using Casio, you're using TI Inspire, TI 84+, you just need to know your calculator in a better way. All the functions are same, but obviously the interface is going to be different. So you really have to get used to your calculator, which is going to be very vital in your DP examination for both Maths AI and AA. Thank you.